And the question is, why does the blockchain have to do all these things? The reason is because of confidentiality, integrity, non-repudiation, and authenticity. That's the goal of hashing. Confidentiality simply means that nobody will have access to the information. You've seen a document that they said is confidential. It means that not everybody have access to it. So that's meaning of confidentiality. Not everybody should have access to it. Everybody have access to the blockchain does not mean that everybody should have access to my transaction. And if they have access to it, they should not be able to understand it. They can only see the hash value of it, the output of it, not the input. And you cannot use the output to guess the input. That's what we call confidentiality. You cannot see it. And if you see it, you are only seeing a hash of it, not the original thing that I wrote. And we're saying that you should have integrity. Nobody can tamper with it. If I send 20 Bitcoin to you, nobody should come on the way to change it to 35 or change it to 15. Nobody should be able to tamper with it. So the data should have integrity, untampered with. So we also have non-repudiation. Non-repudiation means that no denial. I cannot say that I did not send the money or I sent it by mistake. If I've sent the money to you, it will be recorded on the blockchain that I sent some Bitcoin to you. So I can't deny it in the future that I was not the one that sent it. No, I can't deny it. That's what we call non-repudiation. Also, we have authenticity. Is authentic, which means that I'm aware that I'm sending the money to you and you are aware that you received the money. So two of us cannot deny it. I'm aware because for me to send it, it uses my private key. And for you to receive it, it will use your public key. So your information and my information are part of the thing that's being sent. So the data is authentic. There's no denial that I didn't send the money to you. There are proof that you can check and I can check. So it's authentic. That's the reason why we do hashing. Secured hashing function has 3 data security properties: collision resistance, pre-merge resistance, and second pre-merge resistance. I've explained this one to you before, that no two distinct input produces the same hash as output. I've explained it to you with this example that if I type this is a test, it will give me this. If I change it, just change an alphabet from capital letter to small letter, it will change the result. Here it's telling us no two distinct input will give us the same output. If I type A is equals to 1, there's no other thing I will type in the whole world that will give me 1 except A. Only A can give me 1. If I type A, capital A, it will give me 30. It can never give me 1. So that's what we are saying, that only a fixed input can give you a fixed output, or else there'll be collision in the sense that 2 numbers, 2 letters are giving the same output. So for hashing function, we are looking for something that 2 different things cannot give us the same result. We also have what we call pre-image resistance. What's pre-image resistance? It's invisible to find the input from a given output, and this deals with irreversibility. We are saying that if small letter A is equals to 1 and capital letter A is equals to 30, if I see 1, I cannot be able to predict that 1 gave me A. You cannot reverse it. You can't type the output in order to get the input. You cannot. If you type 1, it will give you something different. Let's say 78 or F8. It gives us something different. It will never give us what? A. So that's what we call pre-image resistance. And finally, we have what we call second pre-image resistance. So let me give you an example with your password. Have you ever wondered how your password is secured? So let's type a password. Password 89. So let's say my password is password 89. This is my password that I use on my phone, on my laptop. That my password is password 89. I type it in for my bank. This password is not saved on the database as password 89. No, it is hash and the hash is saved, this is what happens for your daily password. Your company is not saving your original password. Once you type the password, they will hash it. And we say hashing means you are converting this variable input to a fixed output size. So it depends on your company. What is their constant output size? Let's say your company has a 3-digit hashing function. Let's say to give us 777. This is just an example of a hashing function that gives 3 digits. Some have 5 digits, some have numbers and letters, alphanumeric. Just to make it simple, I'm just using 3 digits. So if I type password 89, the company will hash it and they will save 777. That is the way your password is being saved. So now, if somebody have access to 777, they can never predict that my password is password 89. Because if you type 777 into my computer or their computer, it will not give password 89. It will give something different, like 823. It will give something different, something way different. So that's why I was saying that if there's a password here that gives an output size, you cannot reverse it. Now, hackers and scammers are on a whole new level. So what they do most times is not to be typing your password 777, no. They will go and look for what we call a rainbow table. A rainbow table has a list of popular password and their hash value. So they have a list of popular password. Let's say John. It has the value of John. Let's say 2293. It has my password 89. And password 89, they have it as 777. So this table that have a list of popular password and their hashes is what we call rainbow table. So what the hacker will do is just to have access to this table and be checking for 777. He will go and trace it to this 777. To get 777, the person must have typed password 89, because only password 89 will give us 777. So the hacker now will go to his laptop and sign in with password 89, with my own password. And of course, password 89 will definitely give 777, and he will have access to my information and start stealing my money. So, but what most companies do to prevent this problem is that not everybody should have access to a list of password hashes. Not everybody should have access to it. And even if they have access to it, they add what we call short hashing. Short hashing is putting a number in front of it that will change the entire value. So instead of password 899, they will put a number in front. Let's say 8. So 8777. So when the person types the popular password and sees 777, and this one is 8777, he cannot understand it anymore. It has become different. 8777 is different from 777. So the process of doing that is what we call short hashing. What we are saying in cryptocurrency is that nobody should have access to a list of hashes. This rainbow table, we are saying that it should not exist for cryptocurrency. So if anybody by mistake sees 777, there's no reference point to check to know that 777 will give you password 89. It should never be. So rainbow table should not exist for cryptocurrencies so that the system will be secured. And that's what we call second pre-image resistance. It means it's invisible to find any second input that collides with a specified input. So rainbow table, which is a list of passwords and their hashes, should not exist for cryptocurrencies, or else someone can be able to do a reverse engineering and know your password. So you see what cryptocurrency and blockchain has to undergo through in order to be secured. This hashing function I've explained to you is not only used in cryptocurrency, it's used for your passwords. It's used for database lookup. It's used for large file analysis. It's used for data management, digital fingerprinting, encoding, message authentication. It's also used for storing password. Now you know how it's being saved and secured. So that is the same process that's being used in cryptocurrency.